Today's problem is add binary. And to solve this problem, we'll first as always go through the problem statement. We are given two binary strings, A and B, and we just have to return as an output their sum as a binary string. We'll just go through the constraints first before we go dive deep into the examples. We see that A and B are ranging from 1 to 10 to the fourth, and they are only consisting of, like, this is their length, and they are only consisting of 0 and 1 characters. One of the good questions that you can ask your interviewer is that are the strings padded from into the left side by zeros? Do they have any leading zeros? So example would be like this. And as you can see from the constraints, we don't have any leading zeros, so this will be equal to this. I can just cross the zeros. And we'll go through both examples because that will by hand, and because that will enable us to formulate the approach. And we will basically use the same approach as we did in elementary schools when we were adding up two numbers to, for example, 55 plus, I don't know, 63. You would go from left to right, and you would first do addition of 5, 3, which is 8, and then you do 5, 6, which is 11. You would place first the 1, and then carry over the 1 that you got because it's over 10, and then you would place it here, and that would be the solution to the problem. We'll basically do the same for this problem, but the only difference is that it's a binary representation. So it's we have to derive special rules for it. So we'll first go through the first example, which is we have only 1 and 1. Let's just do that. And I copied over our second example, but let's just go through the first example. So we have the following. So 0 plus 1 is 1. And when we are adding like this, 1 plus 1 is basically 2, but if you are adding them like this, we will do the 0 here and then carry over the 1, and we will get the 2. The other special case is if we have, for example, like this, we are carrying over 1. So 1 plus 1 is 2, and we're carrying 1, and then 1 plus 1 is 2, but so we would place 0, but we have 1 from this, from the last sum that we did. So we will place 1 and carry over the 1. So basically we can have 4 results. We can have 0 plus 0, which is 0. We can have 0 plus 1, which is 1. We can have 1 plus 1, which is 2. And then we can have 1 plus 1 plus, I will just put it in the brackets because this is the carry that we do, which will be 3. So this is the carry that we do from the last operation, because we are only summing up two numbers, and they are ranging from 0 to 1. So yeah, this is the only 4 scenarios that we can have. So to use this formula for this example, we'll have 1 and 1, which is 2. We will place 0, and we will remember to carry 1. So 1 plus 1, 1 plus 0 is 1, but we have another 1, so it's 1 plus 1 plus 0, which is 2. We will place the 1. We will place the 0 and carry again the 1 to the next, because we don't have anything here. It will be 0 plus 0, which is 0, plus the 1 that we carry, and we will get the answer. So for this example, we will have the following. 0 plus 1 is 1. 1 plus 1 is 2. We will place that we don't have anything to carry, so 1 plus 1 is 2. We will put the 0 and carry over the 1. So in this example, in the next iteration, we will have 0 and 0, which is 0, but we are carrying the 1, so it will be 1. We are carrying nothing to the next iteration. We will have 1 plus 1, which is 2. We don't have anything from the last, so it will be 0, and we carry over the 1, and our final resolution will be this. So next, we will try to transform this to Java code, but as you can see, we will start from the end of the strings. So we are calculating with left to right, actually right to left. This direction, we will start with the last bits and continue until we reach the end of both strings, or we don't have anything to carry over. So let's see how this is going to look like in the Java code. Let's solve the problem in Java programming language. First, because we're using Java, we will use string builder to create our resulting string, which is the sum of the two strings given by the input. And as from our examples, we will start from the end of the both strings and do the calculation until we reach the start of that. So to do that, we'll have two iterators, two pointers. You can say I, which is pointing to the last bit, you can say, of the string A, and J, which is pointing to the last bit of the string B. And we will also we will define the carry as 0 first, and we will iterate over until we reach either end of both, actually the start of both strings. So we are out of boundary for both strings, and that will happen when we go under 0 for both pointers I and J. And the special case is when we ended up at the start position of both strings, but we still have a carry that's larger than 0, so we can set the next bit as 1. And so we will do our while loop will go through until we have at least one valid statement, one valid statement of these three. And we will have a helper sum variable that will just serve as a sum in each iteration of the loop. And first we will, for the pointer I that's pointing to the string A, our first string, we will check what we have at the current position. And if it's a valid, if it's an in boundary of the string A, we will get the string by using the char at method, and we will also subtract the character 0 so we can get the integer. It's just Java trick to get the integer. If you can say the character is 0, when you subtract 0, it will go to integer value of 0, and if it's 1, we will have the integer value of 1 because it's only one position shifted to the character 0 in the ASCII code. And then we will just basically add that to our temporary sum variable that we use for during each iteration. We will basically do the same for our string B using our J pointer, and then we will also sum the carry that we have currently from the last iteration. As in the first iteration, it will be 0 because we are just starting. Then we will see what scenario we are in. So if the sum is 0 or the sum is 1, we will just append the bit to our resulting string using the string builder, and we will set the carry to 0. But if it's larger, it can be 2 or 3. Remember the cases that we have. It's either 1 plus 1, which is 2, or 1 plus 1 plus 1, and the last one we are carrying from the last iteration, so it's 3. And so we will set the carry to 1. We know that we have to do that, but what do we set the bit of the resulting string? The bit of the resulting string will use just the trick here, modulo. So if it's 2, it will be 2 modulo of 2, which is just 0, or if it's 3 modulo of 2 will be 1. So you will get the correct strings. If it's 3, we will set it as the bit will be set to 1, and if it's 2, the bit will be set to 0, and in both cases we are carrying over the 1. Next, we will, because we started from the end and moved to the start of the strings, our resulting string that we built using the string builder will be in a reversed order. So we will just use the method of string builder to reverse our string and convert it to a string. We're using the toString method and return it as our final solution. The time complexity is proportional to the length of the longest string that we get, because we are iterating over as long as we have at least one valid pointer. So that means that the maximum string will the string that's longer will dictate the time complexity. You can make a case that for space complexity we have the same thing, but generally we don't count the complexity required to declare the resulting structure that will result as a function as a result of the function towards the total space complexity. So we can say that we have a constant space complexity because we didn't use any additional data structure to help us solve this problem.